In an era of escalating temperatures and surging energy bills, the pursuit of comfort often comes at a steep price. Our reliance on conventional air conditioning systems, while providing immediate relief, contributes significantly to carbon emissions and places immense strain on our power grids. As summers grow hotter and energy costs climb higher, many homeowners find themselves trapped in a cycle of expensive cooling, a cycle that seems to have no end in sight. We are constantly searching for new, more efficient ways to cool our homes, yet perhaps the answer lies not in futuristic technology, but in ancient wisdom. What if there was a way to maintain a perpetually cool home, even in the scorching heat of summer, without a single compressor, refrigerant, or a massive electricity bill? What if this solution cost less than a single service call for your existing AC unit, and could potentially last for generations? Such a concept might sound like science fiction, but it is, in fact, an ingenious method rediscovered and championed by communities known for their commitment to self-sufficiency and sustainable living. This isn't a new invention, but rather a profound re-understanding of our planet's natural mechanics. The secret lies beneath our feet, the Earth itself. Just a few feet below the surface, the ground maintains a remarkably consistent temperature, largely unaffected by the daily and seasonal fluctuations of the air above. This thermal stability is a fundamental principle exploited by a system often referred to as an earth tunnel or cold tube. It leverages the planet's massive thermal mass to passively heat or cool air, making it an incredibly powerful, yet simple, form of geothermal exchange. It's a natural phenomenon that has provided shelter and comfort to various cultures throughout human history. Imagine achieving consistent indoor temperatures of around 55 degrees Fahrenheit, year-round, for an initial investment that could be as low as $300. This isn't a hypothetical figure for a minor upgrade, it's the approximate cost for the core components of a functional earth tunnel system, especially for those with DIY skills and access to basic tools. This astonishing affordability stems from the system's inherent simplicity, primarily pipes, fans, optional, for forced air, and the earth itself. Compared to the thousands spent on conventional HVAC, the financial barrier to entry for this sustainable alternative is almost non-existent for many. The promise of a home maintaining a constant 55 degrees Fahrenheit may sound modest to those accustomed to frigid air conditioning, but it represents an optimal, stable temperature that requires no active energy input once installed. While 55 degrees Fahrenheit serves as a baseline for the Earth's natural thermal exchange at certain depths, slight variations can occur based on local climate and system design. Yet, the core principle remains a consistent, comfortable coolness that dramatically reduces the need for energy-intensive mechanical cooling. It's not about making a house freezing, but about making it resiliently comfortable. The Amish community, renowned for its commitment to simplicity, self-reliance, and sustainable living, often embraces technologies that align with these values. While not exclusive to them, the principles behind the earth tunnel resonate deeply with their philosophy. They seek solutions that are practical, durable, and respectful of natural resources, avoiding the complexity and dependence associated with modern utilities. This embrace of passive, nature-based systems highlights a wisdom often overlooked in our pursuit of high-tech fixes, reminding us that sometimes, the simplest methods are the most effective and resilient. At its heart, an earth tunnel is remarkably straightforward. It consists of a series of pipes buried at a specific depth and length beneath the ground. Air, often drawn from outside or from within the home, is pulled through these buried pipes. As the air travels through the cooler earth, it transfers its heat to the surrounding soil. By the time the air emerges from the other end, it has been naturally cooled, ready to be circulated into the living spaces. This continuous exchange of thermal energy requires minimal to no mechanical assistance, making it a truly passive system. The effectiveness of an earth tunnel heavily relies on two critical parameters: the depth and length of the buried pipes. Typically, pipes are buried at least 6 to 10 feet deep, where seasonal temperature fluctuations are minimal. The longer the total length of the pipe run, the more contact time the air has with the cooler earth, allowing for greater heat exchange. A common design might involve hundreds of feet of piping, laid in trenches or coiled patterns. These dimensions are crucial for optimizing the system's performance, ensuring maximum thermal transfer and consistent cooling. The choice of pipe material is also a significant consideration. High-density polyethylene, or HDPE, is a popular choice due to its durability, resistance to corrosion, and excellent thermal conductivity. PVC pipes are also commonly used, offering a more budget-friendly option, though their thermal properties might be slightly less efficient. The interior surface of the pipe should be smooth to minimize airflow resistance and prevent the accumulation of moisture or debris. Selecting the right material ensures the longevity and optimal performance of the entire cooling system for decades to come. While the core principle is entirely passive, how air moves through the tunnel can vary. In some designs, natural convection is sufficient, relying on the stack effect or wind pressure to draw air through the pipes and into the home. This is the purest form of passive cooling. However, for greater control and higher airflow, a low-wattage fan can be incorporated. This active element still consumes significantly less energy than a conventional AC unit, merely assisting the natural thermal exchange. The choice often depends on climate, home size, and desired airflow rates. Interestingly, an earth tunnel isn't just a summer cooling solution. The same principle that cools air in summer can also provide a degree of preheating in winter. As frigid outdoor air passes through the warmer earth, it picks up residual heat before entering the home, reducing the load on conventional heating systems. While it may not bring the air to full room temperature, it can significantly temper the incoming cold, leading to substantial energy savings. This dual-season functionality makes the earth tunnel an even more compelling sustainable technology. For those with a shovel and a bit of determination, the initial setup of an earth tunnel can be largely a DIY project. The most labor-intensive part is digging the trenches to the appropriate depth and width. Once the trenches are prepared, the pipes are laid, connected, and then covered with soil. Proper grading and sealing are important to prevent water infiltration. While larger, more complex systems might benefit from professional excavation, the fundamental installation process is accessible to many, further contributing to its low overall cost and appeal to self-reliant communities. One of the most attractive aspects of the earth tunnel system is its minimal maintenance requirements. Unlike conventional HVAC units that demand regular filter changes, refrigerant checks, and professional servicing, an earth tunnel, once properly installed, can operate for decades with little to no intervention. The pipes are protected underground, shielded from environmental wear and tear. Occasional checks for debris at the air intake and ensuring proper drainage are typically all that's needed, making it a truly set-it-and-forget-it solution for home comfort. When comparing the environmental impact of cooling systems, we must consider embodied energy, the energy consumed by all processes associated with the manufacturing, transportation, and construction of a product. Modern AC units are complex machines requiring significant embodied energy. An earth tunnel, conversely, has a remarkably low embodied energy footprint. Its primary components, like pipes, are relatively simple to produce, and the fuel, the earth itself, is abundant and freely available. This makes it an incredibly sustainable choice from a holistic energy perspective. Unlike many large-scale cooling towers and industrial HVAC systems that consume vast amounts of water, the earth tunnel operates without any need for water consumption for its cooling process. This makes it an incredibly water-efficient solution, particularly valuable in regions facing water scarcity or drought. While condensation may form within the pipes under certain humidity conditions, a properly designed system includes drainage to prevent accumulation, further emphasizing its low environmental impact and self-contained nature. It's a truly dry cooling system. A common concern with earth tunnels relates to indoor air quality, specifically the potential for mold growth or radon gas infiltration. However, these issues are largely preventable with proper design and installation. Using smooth, impermeable pipes, ensuring adequate drainage for condensation, and maintaining sufficient airflow are crucial. Additionally, a radon mitigation system can be integrated if the local geology presents a risk. With careful planning, an earth tunnel can deliver fresh, cool air without compromising health or comfort, debunking myths about inherent dangers. Integrating an earth tunnel into an existing home or new construction requires careful consideration of ductwork and airflow. the cooled air needs to be effectively distributed throughout the living spaces. In new builds, this can be seamlessly integrated into the architectural design. For retrofits, it might involve connecting to existing ductwork or creating new passive vents. The aim is to create a gentle, pervasive coolness rather than a blast of cold air, ensuring thermal comfort is achieved through subtle, consistent temperature moderation. It's about thoughtful design, not brute force. The beauty of the earth tunnel system lies in its scalability. A small system with a single run of pipe can be sufficient for a tiny home, shed, or even a pantry requiring consistent coolness. Larger homes or commercial buildings might require multiple, parallel pipe runs, possibly connected to a central air handling unit. The principles remain the same, only the dimensions and complexity increase. This adaptability makes it a versatile solution, applicable across a wide range of building types and sizes, from humble homesteads to more substantial structures. The earth tunnel is more than just a cooling system, it's a testament to a philosophy of self-reliance and intelligent resourcefulness. It represents a departure from dependence on external energy grids and complex, fragile machinery. By tapping into the abundant, stable thermal energy of the earth, communities like the Amish have long demonstrated that comfort and sustainability can go hand in hand, without sacrificing personal autonomy. This legacy of ingenuity offers a powerful counter-narrative to our increasingly interconnected and vulnerable modern infrastructure. In a world grappling with climate change, rising energy demands, and the vulnerabilities of centralized power, why aren't simple, effective solutions like the earth tunnel more widely adopted? The answer is complex, rooted in a confluence of economic incentives, regulatory frameworks, and societal expectations. Our modern economy thrives on consumption and replacement, creating a formidable barrier for systems designed to be durable, low-cost, and maintenance-free. This fundamental clash between sustainability and economic models creates a dilemma that passive cooling technologies constantly confront. The traditional cooling industry, built on the manufacturing, sales, installation, and servicing of complex mechanical systems, faces a direct challenge from passive solutions. A $300, low-maintenance earth tunnel means fewer expensive units sold, fewer service contracts, and less demand for proprietary parts and refrigerants. From a purely business perspective, this simple technology represents a significant threat to established revenue streams. It's an economic reality that often dictates which technologies are promoted and which are quietly marginalized, regardless of their environmental or consumer benefits. Here lies the crux of the claim: the cooling industry made illegal. It's rarely an explicit ban. Instead, it manifests as a labyrinth of regulatory hurdles and an absence of standardized building codes that make widespread adoption incredibly difficult for the average homeowner or builder. Many conventional building codes are designed around mechanical HVAC systems, overlooking or actively complicating the approval process for passive, non-standard solutions. Without clear guidelines, permitting becomes a nightmare, effectively discouraging, if not outright preventing, their implementation in many jurisdictions. One major obstacle is the lack of standardized design and installation guidelines for earth tunnels. Unlike HVAC systems, which have rigid specifications and certifications, passive earth systems are often site-specific and rely on local conditions. This makes it challenging for building inspectors, who are trained on conventional systems, to assess their safety and effectiveness. Without universal standards, widespread adoption becomes problematic, as each project must be evaluated on a case-by-case basis, increasing costs and uncertainty for developers and homeowners alike. From a regulatory standpoint, concerns about potential health risks like mold, radon gas, or poor indoor air quality are often cited, even if these can be mitigated through proper design. For building authorities, approving an unproven or non-standardized system carries perceived liability risks. It's often safer, from their perspective, to stick to established, approved methods, even if they are less sustainable or more expensive. This cautious approach, while understandable, inadvertently stifles innovation and prevents the adoption of perfectly viable, environmentally friendly alternatives. While direct legislative action to ban earth tunnels might be rare, the influence of powerful industry lobbying groups cannot be overstated. By funding research that highlights potential downsides of passive systems, promoting restrictive codes, and advocating for policies that favor their own products, the cooling industry can effectively shape the regulatory landscape. This often creates an uneven playing field where sustainable, low-cost alternatives struggle to gain traction against the well-funded interests of established mechanical cooling manufacturers and installers. For earth tunnels to gain wider acceptance, a concerted effort is needed to establish clear, science-backed design standards and certification processes. This would alleviate regulatory concerns, reduce liability risks for builders, and provide assurance to homeowners. Projects that successfully integrate these systems, coupled with independent performance data, could pave the way for broader legitimacy. It's a slow process of education and demonstration, but one that is essential for passive cooling to move from niche application to mainstream adoption and challenge incumbent technologies. Despite the hurdles, the fundamental principles of the earth tunnel are being re-examined and integrated into modern sustainable architecture. Contemporary earth-air heat exchangers (EAHEs) incorporate advanced materials, improved airflow designs, and smart controls to optimize performance and mitigate risks. These systems are essentially refined versions of the traditional earth tunnel, demonstrating that the core concept is sound and adaptable to modern building practices. They represent a bridge between ancient wisdom and cutting-edge ecological design, proving the longevity of the idea. While regulatory battles continue, a vibrant DIY community is actively experimenting with and implementing earth tunnels on their own properties, often in areas with less restrictive codes or on off-grid homesteads. Online forums and communities share designs, lessons learned, and performance data, fostering innovation from the ground up. This grassroots movement underscores the accessibility and effectiveness of the system, demonstrating that independent individuals can, and are, reclaiming control over their home's environmental footprint and comfort without waiting for industry approval. For the homeowner, the cost-benefit analysis of an earth tunnel is compelling. The initial low investment of around $300 for materials, combined with virtually zero ongoing energy costs for cooling, presents an unparalleled return. Over the lifespan of the system, which can be decades, the savings on electricity bills alone would far exceed the initial outlay, not to mention the environmental benefits. It offers a tangible path to energy independence and long-term financial relief, an attractive proposition in an era of unpredictable energy markets. Beyond personal savings, the widespread adoption of earth tunnels could have a profound positive impact on the environment. Reducing reliance on energy-intensive AC units would significantly lower carbon emissions, decrease the demand for harmful refrigerants, and lessen the strain on power generation infrastructure. It aligns perfectly with principles of environmental stewardship, offering a practical, scalable solution to mitigate the climate crisis at the household level. It's a technology that truly works with nature, not against it, for collective good. As global climate patterns shift and extreme weather events become more frequent, the resilience of our homes and infrastructure will be paramount. Systems like the earth tunnel, which operate independently of vulnerable power grids and rely on stable natural forces, offer a pathway to greater household resilience. They provide a foundational level of comfort and habitability even during power outages or periods of intense heat, ensuring safety and well-being when conventional systems fail. This foresight in design is more crucial than ever. The story of the $300 earth tunnel is not just about a cooling system, it's about challenging the status quo. It asks us to question why simpler, more sustainable solutions are often overlooked or actively hindered in favor of complex, resource-intensive alternatives. It highlights the tension between established industries and innovative, disruptive technologies that threaten their models. By understanding these dynamics, we can advocate for policies and practices that truly serve the long-term interests of homeowners and the planet, rather than just corporate profits. Ultimately, empowering homeowners with choices means providing access to a diverse range of cooling solutions, from high-tech smart systems to low-tech passive methods. The earth tunnel offers a powerful, affordable choice for those seeking to reduce their environmental footprint and achieve energy independence. Its suppression, whether through direct legal action or indirect regulatory hurdles and industry influence, limits these choices and perpetuates reliance on less sustainable options. We must demand a more open and equitable playing field for all forms of sustainable innovation. The Amish system, in its essence, represents a continuity of human ingenuity that has long understood and respected the natural world. It reminds us that often, the most elegant and effective solutions are not new, but rather forgotten or marginalized by technological advancement and industrial imperatives. By looking to these enduring principles, we can rediscover paths to living in harmony with our environment, building homes that are not just comfortable, but truly sustainable for generations to come. The past holds lessons for a resilient future. It's time for a renewed call to innovation that prioritizes sustainability, affordability, and resilience over short-term profits and entrenched interests. This means revisiting and modernizing passive solutions like the Earth Tunnel, creating clearer regulatory pathways, and fostering an environment where ingenuity can flourish regardless of its commercial viability for existing industries. The future of home comfort and environmental health depends on our willingness to embrace a broader spectrum of solutions, old and new, and to overcome the inertia of the status quo. As viewers, your interest and advocacy play a crucial role. By understanding these systems, asking questions, and supporting sustainable building practices, you contribute to a growing demand for alternatives. Whether you're a homeowner, a builder, or simply an engaged citizen, your voice can help push for regulatory reform and greater acceptance of passive cooling technologies. The power to shift the narrative and embrace a more sustainable future for home comfort truly lies in our collective hands. The Earth Tunnel, a simple, elegant solution rooted in millennia of human understanding of natural forces, stands as an unsung hero in the fight for sustainable living. It's a testament to the idea that sometimes, the most effective answers are the simplest ones, hidden in plain sight, or buried just beneath our feet. Its journey from ancient wisdom to Amish tradition, and now facing modern regulatory challenges, highlights a timeless struggle, the battle between what is truly good for people and planet, and what is merely profitable. The future might just be underground.